Hello and welcome to today's video. Today we're introducing notation concerning sets of numbers. We work with a few sets of numbers frequently, and that's why we use shorthand notation for those. And the idea of this video is basically to summarize the most common sets that we will have to deal with. So this is again part of the introductory series. I call this sets of numbers. Now, I'm not going to go into detail on how those sets are defined, what certain kinds of numbers actually are from a mathematical viewpoint. I'm just going to introduce the notation in this little video here. So we introduce commonly used sets, namely the following. Let's start with the so-called natural numbers. Now those are usually denoted by n, blackboard n with this double stroke here. And by the natural numbers, what I mean is the set of numbers 1, 2, 3, 4, 5, and so on. So those are the natural numbers. Notice in my notation, they do not include 0. In some books, you will find this notation n meant to include 0. If I want to do that, then I would write n and a subscript 0. So that means the natural numbers including 0. Okay, so I'll make this explicit. Now, if you actually want to work with the numbers, if you want to add or subtract numbers, then the natural numbers are not sufficient. You will have to add negative numbers as well. And that is what the set of integers does. That set is denoted by set. And what I mean is the set of all negative numbers, this 0, and then the set of all positive natural numbers. Okay, so this is a set where you can meaningfully do addition and subtraction. Next step, once you can do addition and subtraction, the next natural step is to do multiplication and division. And for that, we introduce the rationals. Those are denoted by Q. And those simply consist of all fractions of integers. So all a over b, where a and b are integers. These are the rational numbers. The set of numbers that we will be mostly concerned with are the real numbers. And in addition to the fractions, those also include irrationals. So, for example, square root of 2 or pi or Euler's number e. Those are numbers that are contained in the real numbers, but not q maybe. Yeah. So the real numbers, we'll denote those by r. Again, I'm not going to talk about the definition of those numbers. That's not a very easy topic. It's a nice topic, actually, but we won't discuss this in the context of this class here. So that's the set we'll mostly work with. I'd just like to list one more set for the sake of completeness, more or less, and that is the set of complex numbers. We will not discuss complex numbers in this first semester. We will discuss them in semester 2. But you might encounter them in literature at some point. So that's why I introduced the notation right now. complex numbers. That is denoted by C, again with a double stroke. Okay, so that set of complex numbers basically is the set where you can solve all possible equations, actually have a solution. Yeah. For example, you can solve the equation x squared equals -1. You can do that over C, and you can pretty much solve every polynomial equation of the set, which is not possible on the real numbers. That's one of the possible motivations for introducing the complex numbers. And as I said, we'll talk about this more in semester 2. So that's pretty much all about notation for numbers. I'd like to introduce one more shorthand for a restricted set. We'll often refer to positive real numbers, negative real numbers, or non-negative, non-positive real numbers. For those, I'm using a convenient shorthand. Those will be denoted by something like R, and then I'll have an index that indicates which part of R I mean. Here, for example, R greater or equal to 0. That means the non-negative reals. Right? So all real numbers, all x in R, where R is greater or equal to 0. X is greater or equal to 0, sorry. Similarly, we'll define the positive real numbers as R greater 0. And the negative reals are less than 0. And of course, there's also the non-positive reals. Those will occur less frequently, but there's also a notation for those. Okay, so these are some shorthands that we will use whenever they are convenient. So that concludes our introduction into this notation of sets of numbers. In the next video, we'll talk about sets in particular a little more, and we'll also introduce intervals.